the thing.
Thank you very much.
All right, I'll stand in the corner.
Okay, yes, so,
okay.
Thanks Rich. So I work for Rich, and I'm part of the dog food, and if you like. We try to use Nokia's products as soon as we can get them. So we've been, for the last 5 months, using QML. And to be honest, we've been having a lot of fun using it. And we've really come to the conclusion that it is pretty great. And I think just the reason we think it's great is because it just encourages simple, elegant code. And this code, when it runs, it's robust and it's performant. And it just seems like the nirvana for us. And we've had a lot of fun. So what I wanted to do, I've got 5 minutes, and I really want to use that time to try to show to you how simple and elegant QML is, and how efficient it is as well. So I want to do that through a demo. So this is where we try the technology. So I've got here running, on a mobile phone, a simple QML program. It's an album browser, just the usual album browser you get on mobile phones. But the difference is here we've written this in QML. And I think I wrote this code the first week I used QML. And I wrote it because I thought I wanted to find out whether QML was performant, and I wanted to find out how easy it was to write this sort of thing. So, we'll be trying to switch back. Right, so if we want to build an album browser in QML, we have some choices. We need to manage a list of albums, so we can use a list view that manages a list of code, a list of elements, but we can also use something called the path view because it actually provides us with a way of animating a number of items on the screen across a defined path. So obviously if we're going to use a path view, we need to define a path. And this is where QML gets really quite nice and very easy to use, but it becomes very powerful very quickly. So as you might imagine, a path, you define it by its points, and you define it by how you join those points together. So we talk in here, we've defined 5 points. We've defined 2 lines and 2 quadratic curves to join those points together. QML also, or the path view element, allows us to actually specify how the distribution of those points across that path as well, so we can see we can bunch up the albums on the left and the right-hand side, and we can have less in the center. And we can also define our own attributes, so we can put any attributes we like on the path, and we can define their values at each point on the path. So we have scale of the artwork, and rotation on the y-axis, and the z order. And you can see how these vary across the points, and the path view will interpolate then in between these points. So wherever we are on the path, we'll always get a good representation of these attributes and get a smooth animation. So as well as a path, we also need to define a model, which is basically access to our database to get hold of the albums that we have on the device, the artwork, album names and artists, etc. And last but not least, we need to define something called a delegate. And this delegate allows us to, well, as the name implies, it's responsible for drawing a part of the scene. It actually is responsible for drawing one item on the path, and in this case, that's one album. But of course, it must do that in a way that's compliant with the album view, so it needs to draw it transformed with the right rotation and scale, and with a reflection. So we're all developers here, so let's cut to the code. So if we look at the path view itself, we'll first look at QML. It's very declarative, lots of properties we're defining and binding. We start with an ID. We also then use the anchors mechanism, which we can use to fill our parent or to justify ourselves within a parent, or even anchor to other components in the scene. Which is a very powerful mechanism for actually laying out your components, which really helps when you've got a freely animated scene. We need to say how many items we want on the path at one time, so in this case we want 13 albums on the screen at one point. We also then need to specify which elements are actually implemented in the path, the model, and the delegate, and we refer to those with our IDs. There's some code here to set the focus so that we can make sure that every time we run an animation, it always stops dead center halfway along the path, so that we all get this nice animation where the albums always stop right in the center of the screen. And we can also mess around with the kinetics, so we can affect the flip deceleration to get the effect that we want. It's a very simple code and very little code. Now for the path, then, again, we're declaring a path, so you'd expect to see some code to declare a path. So we start with creating our first point. We define the attributes that we want, our rotation, scale out, and Z order, and their values at point 1. And then we start drawing lines, or defining the lines to the next point. We can then also specify how much content we want on that line, and also then the attributes at point 2. And then we do the same for 3, although we're using a curve, and we can do the same for 4 and 5. Not enough space on the slide, but there we are. Then the model. Very simple, one function, one JavaScript function. All it's doing is opening a database and executing a SQL transaction, just to select, pull out all the albums, and then in each row of the cursor, then we're just appending to the model album name, artist name, and album art. And those names are significant. Those are the names that we refer to actually get hold of this data when we go and render this in the delegate. And finally, but certainly not least, the delegate. So remember, the delegate, its responsibility is to render one album on the path, and so it must do this based on the parameters that are set by the path view, and also use the model to get hold of the right artwork. So you can see the first thing it does is set the Z order based on what the path view is saying. It then defines an image, uses the source as the album art from the model, and then applies a transform using the rotation and the scale. And this is a simplified version of the delegate because it hasn't got the reflection in it, but you can imagine the reflection is just another image transformed slightly differently with a gradient semi-transparent rectangle put on top of it. So we're only talking about another 20 lines of code. And that's it. That's all of your code. So that's everything you need. Maybe you need another 5 or 6 lines to put the text to say which album name it is, and a few lines just to instantiate the elements. But you're still only into 130 lines of QML to do an album view like that. And, you know, I'd never used QML before, and I could write that in a day. If you know what you're doing, you can write it in an hour. And it works. You know, how many if statements do you see? There's no, the code paths to follow here are so simple. You know, I haven't put any comments in the code here at all. I'm just explaining the code to you as it is. And for me, this is simple, elegant. It's robust. Since I've written it, I've never had to change it. I've used some hard-coded values here, but you can put ratios in, so it works in many different screen resolutions. And it's performant. It runs really fast on our phones. It runs fast on our desktops. So that's why we think QML is great. Okay, thank you very much.